Persian cities maintained comfortable indoor temperatures throughout brutal desert summers for 3,000 years, using a sophisticated underground cooling infrastructure that consumed zero electricity. The system, called the Qanat, delivered cool water and cool air to homes, businesses, and public buildings across cities where summer temperatures regularly exceeded 110 degrees Fahrenheit. Iranian engineers developed and refined the Qanat technology across millennia, creating networks that remain partially operational today in cities including Yazd, Kerman, and Kashan. The system combines underground water channels with carefully designed air towers called badgirs that capture surface breezes and channel them through cooled spaces. The resulting cooling effect reduced indoor temperatures 20 to 35 degrees below outdoor conditions, providing genuine comfort during the hottest summer periods without any active cooling equipment. The principles underlying Qanat cooling apply anywhere with sufficient water tables, sustained breezes, and willingness to invest in appropriate infrastructure. While full Qanat systems remain impractical for American residential applications, simplified versions of the same principles can provide substantial cooling benefits in appropriate American climates at modest cost. Understanding these ancient techniques provides insight into passive cooling approaches that modern Americans typically overlook in favor of energy-intensive mechanical air conditioning. The basic Qanat concept involves horizontal underground tunnels that collect groundwater from aquifers in mountain foothills and channel it by gravity to cities in valleys or plains below. These tunnels, typically measuring 3 to 6 feet in diameter and extending 10 to 40 miles in length, tap water sources at depths where temperatures remain cool year-round. As water flows through the tunnels toward its destination, it picks up and retains the cool underground temperatures, typically around 55 to 62 degrees. Vertical access shafts positioned every 60 to 200 feet along the tunnel length provide maintenance access while also enabling air exchange that cools surface buildings along the route. The cooling applications of Qanat systems took several forms across Persian civilizations. The simplest application involved directing cool water from qanats into courtyards and interior spaces, providing evaporative cooling from water surfaces and direct radiant cooling from the water itself. More sophisticated applications channeled Qanat water through pools or fountains integrated into buildings, providing humidifying and cooling effects to surrounding interior spaces. The most elaborate systems combined water cooling with air towers that captured surface breezes and directed them over Qanat water surfaces, producing cooled air that then flowed into interior spaces through carefully designed passages. The Badgir air tower component of sophisticated Qanat-cooled buildings represents a distinct engineering achievement. These tall towers, typically rising 20 to 40 feet above building rooftops, capture breezes at elevations where wind speeds and consistency exceed surface conditions. The captured air flows down through tower interiors, passing over cool surfaces that reduce its temperature before it enters living spaces. Some designs route the descending air over cool Qanat water, producing substantial temperature reductions through evaporative cooling combined with conductive cooling from water surfaces. The cooled air then replaces warm interior air, which exits through other openings in the building. Hassan Farshad, an Iranian architectural historian who has documented Qanat cooling systems across central Iran, has conducted extensive thermal monitoring at historical sites where original systems remain partially functional. His research at the historic city of Yazd documents typical interior temperature reductions of 25 to 35 degrees below outdoor summer maximums in traditional homes with functioning Qanat cooling infrastructure. The thermal effect varies across different times of day and different building positions within the broader cooling network, but consistent substantial cooling effects persist across the traditional building stock that retains Qanat connections. The geographic distribution of Qanat systems extends across arid regions of Iran, Afghanistan, the Arabian Peninsula, North Africa, and parts of Central Asia. Similar systems developed independently or through cultural diffusion in various locations with appropriate conditions, including sufficient groundwater, desert climates, and sustained breezes. Roman colonies in North Africa incorporated Qanat principles into their water and cooling infrastructure. Spanish settlers brought related concepts to colonial Mexico, where they evolved into various regional cooling approaches. The fundamental principles proved effective across diverse cultural contexts wherever appropriate physical conditions existed. The simplified American adaptations of Qanat principles can provide meaningful cooling benefits for appropriate applications. Homes with accessible groundwater can implement reduced-scale cooling systems using well water circulation through heat exchangers or radiant cooling panels. Appropriately designed structures can incorporate air tower concepts using vertical shafts that capture prevailing winds and channel them through cooled spaces. Courtyard designs integrating water features with appropriate shading and ventilation patterns can produce substantial cooling effects at low operational costs. Each adaptation draws on specific Qanat principles while working within practical American residential constraints. Layla Muradi operates an architectural consulting practice focused on traditional Persian design principles adapted for Western applications. Her work has included 19 residential projects across the American Southwest that incorporate various Qanat-inspired cooling elements. Her typical project includes a central water feature with appropriate circulation, vertical wind towers or enhanced ventilation chimneys, thermally massive interior surfaces, and careful orientation to capture prevailing breezes. Total construction cost premium for these integrated design elements typically runs 8 to 15% above conventional southwestern construction, with documented cooling energy reductions of 40 to 65% during summer operation. The water component of Qanat-inspired cooling creates specific benefits beyond pure cooling. Indoor water features add humidity to dry desert environments where low humidity often creates comfort issues, even at moderate temperatures. The sounds of water flow provide psychological comfort associated with cool environments. The visual presence of water transforms interior spaces aesthetically. These multiple benefits make water integration attractive beyond the pure thermal performance considerations. The breeze capture component addresses the challenge of directing prevailing winds through living spaces effectively. Traditional Bajir designs incorporated multiple faces to capture breezes from various directions as winds shifted throughout daily and seasonal cycles. The directional capture ensured consistent cooling regardless of wind direction variations. American adaptations often use simpler single-direction capture, appropriate for locations with consistent prevailing wind patterns, though multi-directional designs work well for sites with variable wind conditions. Cyrus Nazari, a mechanical engineer specializing in passive cooling systems, has documented performance data from 23 American residential installations that incorporate substantial Qanat-inspired elements. His research shows typical cooling energy reductions of 45 to 70% compared to baseline conventional construction in equivalent southwestern climate zones. The homes maintain comfortable interior temperatures throughout most summer conditions without any active air conditioning operation, requiring mechanical cooling backup only during extreme heatwave conditions when even passive systems struggle to maintain peak performance. The thermal mass component that complements water-based cooling in Qanat systems provides important temperature moderation. Traditional Persian courtyard homes incorporated substantial thermal mass in walls, floors, and surrounding structures that stored cool nighttime temperatures for daytime radiation. The combination of thermal mass with water cooling and breeze capture produces cumulative effects substantially exceeding what any individual component would achieve alone. Understanding the integrated system design proves essential for successful adaptation rather than simply implementing individual elements without coordinated overall approach. The operational considerations for Qanat-inspired cooling systems involve specific seasonal and daily management practices. During cool night hours, maximum ventilation flushes accumulated daytime heat from interior spaces, while cool nighttime air pre-cools thermal mass surfaces. During hot afternoon hours, minimum ventilation retains cool conditions, while thermal mass and water features absorb heat gains from any unavoidable infiltration. Transitioning between these modes requires user attention and awareness, unlike automated mechanical systems that operate without daily management requirements. Families adopting these approaches must develop operational habits that optimize performance. Now for the obstacles and limitations that affect Qanat-inspired cooling applications in contemporary American contexts. First, the groundwater requirements for effective water-based cooling limit applicability to sites with appropriate water resources. Not all American locations offer suitable shallow groundwater for residential-scale thermal applications. Sites without appropriate water resources must rely on alternative cooling strategies that may prove less effective than water-integrated approaches. Second, the architectural requirements for effective cooling often conflict with contemporary American design preferences. Traditional Persian courtyard homes emphasize internal spaces organized around central water features with minimal exterior windows and substantial thermal mass walls. These characteristics differ dramatically from contemporary open-concept designs with extensive glazing and minimal interior mass. Homeowners must appreciate the aesthetic implications of traditional-inspired designs for these approaches to succeed as living environments. Third, the construction specialization for integrated passive cooling systems exceeds that available from most American contractors. The knowledge required to properly design and construct water features, air towers, and integrated building systems requires expertise in traditional approaches that few builders possess. Qualified contractors typically work in specialized practices serving limited geographic markets, potentially requiring travel or remote consultation for distant projects. Fourth, the maintenance requirements for water-based cooling systems impose ongoing responsibilities beyond conventional building maintenance. Water features require periodic cleaning, equipment maintenance, and attention to water quality to prevent algae growth or other issues. Qanat-style underground water flows require occasional inspection and cleaning to maintain proper flow rates. The maintenance intensity exceeds typical American homeowner expectations and may not align with preferred lifestyle patterns for many families. Fifth, the climate suitability varies substantially across different American regions. Arid climates with substantial daily temperature swings and reliable breeze patterns produce ideal conditions for Qanat-inspired cooling. Humid climates produce poor performance due to humidity interfering with evaporative cooling effects. Climates with unreliable wind patterns may not sustain the consistent ventilation that these approaches require. Assessing local climate suitability proves essential before committing to extensive Qanat-inspired construction. Despite these considerations, Qanat-inspired cooling approaches offer proven performance for applications in appropriate American climates and site conditions. The thousands of years of Persian experience and successful contemporary adaptations provide strong evidence for what can be achieved through thoughtful, integrated design. The educational resources for learning about traditional Persian architecture and Qanat systems have expanded through various publications, academic programs, and cultural preservation efforts. Various American universities include traditional Persian architecture in their sustainable building curricula. Professional organizations support exchanges between American architects and Iranian traditional building specialists. Online resources, including videos, academic papers, and practical construction guides, provide supplementary education. The growing educational infrastructure supports increased American capacity for applying these principles thoughtfully in contemporary projects. The environmental implications of widespread adoption of Qanat-inspired cooling would be substantial in appropriate climate zones. American southwestern cities consume enormous quantities of electricity for mechanical air conditioning during summer months, with cooling loads representing 40 to 60% of total regional electricity consumption. Substantial reduction of this cooling demand through passive approaches would produce corresponding reductions in electrical generation requirements and associated emissions. While full adoption at regional scale remains unlikely given contemporary construction patterns, partial adoption by committed homeowners can meaningfully contribute to regional sustainability goals. Mehrdad Farahani, a civil engineer specializing in traditional water management systems, has documented ongoing operation of original Qanat systems in Iranian cities, where infrastructure has functioned continuously for over 2,000 years. His research shows that properly maintained Qanats continue delivering their intended services across extended timeframes that dwarf the lifespans of any conventional cooling infrastructure. The durability of properly constructed underground water systems exceeds virtually any alternative cooling infrastructure, demonstrating possibilities for long-term thinking in cooling system design that modern engineering rarely considers. The resilience benefits during power disruptions provide meaningful insurance value for families with Qanat-inspired cooling. Traditional passive systems operate completely independently of electrical systems, providing cooling performance that continues unaffected by grid failures, extreme weather events, or other infrastructure disruptions. Families in hot climates face potentially dangerous conditions during extended summer power outages, with mechanical air conditioning unable to function. Passive cooling systems maintain reasonable indoor conditions throughout such emergencies, providing genuine safety protection that mechanical systems cannot match. The economic analysis of Qanat-inspired construction produces revealing long-term pictures that conventional construction accounting typically overlooks. A properly designed passive cooling home in an appropriate climate zone may cost 10 to 15% more upfront than conventional construction. That premium might represent $40,000 to $70,000 additional dollars on a typical southwestern home. Conventional cooling operational costs for an equivalent conventional home in hot desert climates run $2,500 to $4,500 annually when full life cycle equipment replacement is included. Over a 30-year ownership period, those operational costs accumulate to $75,000 to $135,000 in today's money, ignoring inflation. The passive home's operational costs over the same period might total $15,000 to $30,000. The cumulative difference favors the passive construction approach substantially, typically producing $30,000 to $80,000 in genuine lifetime savings even after accounting for the construction premium. These economics improve further when considering that energy prices have historically risen faster than general inflation, making future operational savings worth more than present value calculations suggest. The acoustic characteristics of Qanat-cooled homes differ substantially from conventional mechanically cooled structures. Mechanical air conditioning introduces continuous low-frequency noise from compressors, fans, and air movement through ductwork. This background noise reaches levels that families adapt to subconsciously, but that measurably affect sleep quality, concentration, and overall physiological stress responses. Qanat-inspired cooling produces almost no mechanical noise. The gentle water sounds, subtle breeze movements, and overall quiet create dramatically different acoustic environments. Research on sound environments and human well-being suggests these differences affect quality of life significantly, despite not being consciously noted by occupants. The shift from mechanical to natural cooling soundscapes represents a qualitative improvement that adds to the thermal and economic benefits. The adaptation patterns observed among families transitioning from conventional to passive cooling reveal interesting psychological and behavioral shifts. Initial transitions often involve discomfort, as families adjust to temperature ranges slightly different from the narrow bands conventional air conditioning maintains. Traditional Qanat-cooled homes might operate at 74 to 82 degrees across different zones and times rather than the constant 72 degrees mechanical systems attempt to enforce. After adaptation periods typically lasting 2 to 4 weeks, most families report preferring the variable traditional temperatures over the enforced mechanical constancy. The broader temperature tolerance that develops enables significant energy savings while also producing subjective comfort reports that often exceed those associated with conventional cooling. This adaptation phenomenon has important implications for how Americans might think about comfort, energy consumption, and the arbitrary standards that shape conventional residential construction. The integration possibilities for Qanat principles with other passive design strategies create powerful combined effects. Earth-sheltered construction, combined with Qanat-inspired cooling, produces extremely stable interior temperatures with minimal energy input. Solar shading integrated with wind tower ventilation enables effective performance even during extreme heat events. Thermal chimneys that drive ventilation through temperature-induced air movement complement the pressure-driven flow that badgers capture. These combinations often produce cumulative effects exceeding the sum of individual components, with properly integrated designs achieving genuine comfort conditions across climate ranges that challenge any single strategy approach. Nasrin Tavakoli, an Iranian urban planner who consulted on preservation of Yazid's historic district, has documented how Qanat-cooled neighborhoods function as integrated systems beyond individual building performance. Shared Qanat infrastructure reduces per-household costs while providing more reliable service than any individual building could achieve independently. Community-scale water features create microclimates benefiting surrounding buildings. Cooperative maintenance of shared systems distributes responsibilities and costs efficiently. These community-scale dimensions of traditional Persian cooling suggest that full American adaptation might require reconsidering not just individual buildings, but neighborhood-scale infrastructure approaches that contemporary zoning and development patterns rarely accommodate. The research trajectory for contemporary passive cooling continues generating improvements that build on traditional foundations. University research programs at institutions including Arizona State, University of New Mexico, and University of Texas have documented performance data from hundreds of traditional-inspired installations. Engineering firms specializing in regenerative design have refined construction approaches that reduce costs while maintaining performance. Materials science advances have produced thermal mass components, radiant cooling panels, and heat exchange equipment that integrate more effectively with traditional design approaches. The combination of traditional wisdom with contemporary refinement produces solutions that typically outperform either pure traditional or purely modern approaches alone. The water quality management practices associated with traditional Qanat systems offer relevant lessons for contemporary applications. Persian engineers developed sophisticated techniques for maintaining clean water flow across extended underground channels, including careful site selection to avoid contamination sources, strategic placement of settling basins to remove sediments, and periodic maintenance protocols that prevented biological growth. These traditional approaches predated modern filtration technology, yet produced water quality suitable for direct human contact and consumption. American adaptations can draw on these traditional practices, supplemented by modern filtration and treatment technologies to achieve water quality meeting contemporary standards while preserving the essential cooling and aesthetic functions. The governmental and regulatory context for pursuing Qanat-inspired construction varies substantially across different American jurisdictions. Some southwestern communities have incorporated specific provisions into building codes supporting traditional passive cooling approaches. Other jurisdictions maintain requirements designed around conventional construction that create obstacles for alternative approaches. Some areas offer energy efficiency incentive programs that can apply to passive cooling installations. Other jurisdictions remain oriented around mechanical equipment subsidies that don't apply to passive alternatives. Navigating the regulatory landscape requires local expertise and willingness to advocate for appropriate recognition of passive system performance in regulatory frameworks often designed without such systems in mind. The aesthetic integration possibilities for Qanat-inspired elements offer substantial design flexibility. Contemporary interpretations can range from highly traditional Persian-inspired appearances with courtyard organization, geometric patterns, and traditional material palettes through modern minimalist approaches using similar underlying principles in contemporary visual languages. The underlying thermal performance principles operate independently of surface aesthetic choices, allowing homeowners to express personal design preferences while still capturing functional benefits. Architectural firms skilled in traditional principles have demonstrated successful adaptations across diverse aesthetic frameworks, producing homes that reference traditional precedents visibly or subtly according to client preferences. The cultural and aesthetic dimensions of traditional Persian cooling architecture add qualitative value beyond pure thermal performance. The integration of water features, traditional decorative elements, and historically resonant design creates living environments with meaningful cultural richness. Families appreciating these qualitative dimensions often value the overall experience substantially beyond what pure functional analysis would capture. The integration of traditional approaches with contemporary American lifestyles produces unique living environments that neither purely traditional nor purely modern approaches can deliver. Consider what implementing Qanat-inspired cooling principles means for families building in appropriate American climates. The additional investment required during construction produces a home that works with regional climate conditions rather than fighting against them. Summer cooling costs remain dramatically below conventional alternatives throughout the home's life. The living environment provides thermal and aesthetic experiences that conventional construction cannot replicate. The reliance on passive principles rather than mechanical equipment provides resilience against various infrastructure disruptions. The connection to thousands of years of refined traditional practice adds cultural dimensions that add meaning beyond pure function. The opportunity exists for families in southwestern states and other appropriate climates willing to build thoughtfully outside mainstream construction patterns. The Persian civilizations that refine these approaches demonstrated what's possible across 3 millennia of continuous refinement and successful application. Their solutions still work today. The knowledge persists in historical examples, academic documentation, and the work of contemporary specialists who continue studying and applying these approaches. Whether any particular family pursues Qanat-inspired cooling remains personal choice based on individual circumstances, climate conditions, and architectural preferences. The alternative exists. The evidence supports the performance across millennia of documented operation. The traditions endure for American families in appropriate climates willing to build for long-term comfort, sustainability, and connection to proven historical wisdom. The Qanat heritage offers inspiration and specific technical guidance for creating homes that work exceptionally well in challenging desert environments.